Hello viewers, today we will see the mechanical finishes, how advantages are there for making the fabrics look very beautiful and also to get more variety. Mechanical finishes are those that are given by using mechanical operations or machines, and that imparts pressure on the fabric and thus will bring about changes like change in the shape maybe, or change in the surface, or change in the some properties, but not chemically. So, mechanical finishes do not bring any chemical changes in the fabric, but the structure may be little bit changed due to mechanical finishes. If we take mechanical finishes, we have finishes like calendering. Calendering is a mechanical finish that is essentially used for fabrics in order to produce luster and also smoothness in fabrics. Usually after wet processing, the fabric becomes distorted, having more wrinkles and all, and that should be straightened. If you take this calendering machine, this machine may contain rollers, and these rollers are metal rollers mainly, and they revolve against a paper roll, or may contain even a cloth covered roller or cylinder. They revolve against each other, and finally they impart the pressure or the temperature, whatever it may be, or the smoothness to the fabric. Sometimes it may be not only 2, and it may be around 3 or 5 or 7 rollers also may be present. Thus, these metal rolls will bring about the effect that is required in the material. And there are different types of calenderings that we see today, like simple calendering, friction calendering, Schreiner calendering, Moir calendering, and embossed calendering. When you take the simple calendering, it is something like our own ironing domestically, but it differs in the kind of pressure that it exerts on the fabric. So, the fabrics after wet processing and all will be brought over here, and they are partially dried, and then they were allowed to pass through the 2 metal rollers, highly polished, having high temperature, and so there will be a paper roll or cloth covered roll will be there in between these 2. And so, the fabric will first go through the first metal roll and also the paper roll, and again through the paper roll and metal roll, and thus it comes out smooth and without any wrinkles, and also partially dried and having a smooth surface. So, this is a simple calendering, but it exerts a very high pressure, we should say, that is around 140 kgs per centimeter square, and so that the whole fabric gets really ironed very well. And even when you see the domestic irons and all, you find that the light irons will not give that much smoothness and that much good shape and all, but when it is really ironing is done with heavy irons, we find that the fabric will be very smooth and have the neat finish and all. In the same way here also, high pressure is being exerted on the fabrics, and thus we find this calendering machine produces a fabric which is very smooth and lustrous because when the surface becomes smoother, naturally it becomes lustrous. Then coming to the friction calendering. Friction calendering is a type of calendering that produces a glazed surface on the fabrics, something like chintz and all, where the fabrics are not that qualitative, but having a glazed surface will augment their selection. So, as the name says, the friction will be more, producing more luster. In this what happens is, some of the fabrics like cotton chintz, or you can say even satins and some of the fabrics which should be finished without much price added to it. These fabrics need to undergo through the friction calendering. Usually sized cottons and other fabrics will be passed through it. There again, here also they are partially wet when they are sent through this machinery. Here the friction calendering has a big roller and a small roller, a paper roll or something like that. When the fabric passes through these rolls, the speed of the fabric is oriented with the speed of the paper roll. Actually, the metal roll will revolve at a very high speed, And so, what happens when the fabric is going between these two, and the paper roll and also the fabric go a little lower speed when compared to the heavy metal roll. And when it revolves against this one, what happens is it goes and it polishes the surface of the fabric, and thus this friction calendering produces heavy luster in the fabrics. And then coming to Schreiner calendering. In this Schreiner calendering, we can either produce fabrics with temporary finish, or we can even produce fabric with the durable finishes. When it is done on an ordinary cotton fabric or linen fabric or some of these fabrics, then the finish is going to be temporary. When it is done on a resin fabric or something like a thermoplastic fabrics and all, which are heat sensitive, then it is going to be a permanent structure on the fabric. In this, it produces a deep seated luster rather than the shine in the fabrics, and thus it gives rich look and the fabrics look like silk. And so, it is generally given to cotton and other dull fabrics which do not have that much luster, so that the customer or consumer, whenever they go for taking these materials, will be attracted towards the luster that is present. This luster is not just like the friction calendering, this is a deep seated luster and looks like a silk material. In this, there will be a big roller, and which is actually engraved with diagonal lines, and the lines are around 250 to 350 per inch, and thus they can't be seen with the naked eye. You have to use a magnifying glass to see this. And this is not heated here, but the small roller which is present, it is heated to higher temperature. So, the fabric is made to pass between the engraved roller with lines and also the small roller which is having high temperature. The impressions of the lines will be passed on to the fabric here, and this is done at a higher temperature and pressure also, and so the lines will be impressed on the fabric, and thus when the light ray falls on this material, and it gives a deep seated luster to these materials. And so, like cotton satins and also damask fabrics are generally finished by this finish, so that they get the luster like satins. To resemble satin fabrics, these are given this kind of finishing. But this is a very temporary, unless the fabric is coated with a resin or it is made out of some thermoplastic material, this will not going to be durable finish. Then coming to the moire calendering. Moire means it is a watery effect. That means that we will be able to produce watery line effect on the fabric in order to improve its aesthetics and also to bring variety in fabrics. So, in fabrics like rayons, in fabric like cottons and all, this finish can be given. Even for estate materials and all, even for thermoplastic materials, this finish can be given. But the important aspect of this is that we need a ribbed fabric with a prominent rib. So, two fabrics with prominent rib will be taken, and then they are made to have little off grain. They are placed one above the other, little off grain, and then maybe they are held with the help of clamps and other things, or they will be stitched along the edges, and then the fabrics are made to pass through this particular moire roller. In this moire roller, what happens is that one is a big steel roller, and against the cloth covered roller, the temperatures are high and the fabric is made to pass through it, and at a very high pressure of 8 to 10 tons. Then what happens at this high pressure, the ribbed pattern of one of the fabric will be transferred onto that or impressed on the second fabric, or the bottom fabric ribbed pattern will be impressed on the upper fabric surface, and thus you find that the pattern comes on both the fabrics. And then when the fabrics are removed, when they are made cold, and then the impressions will be still there, and when the light falls on that, it ripples over that along the flat surfaces, and thus it gives a watery line effect called the moire. And so, if it is done on cotton fabrics, it is going to be a temporary finish, but at the same time, if it can be done on thermoplastic fabrics, yes, it is going to be very durable. This is one kind of Moir calendering, and there is one more Moir effect that we can achieve by taking engraved roller again. It is engraved with the Moir pattern, and then the other roller called cloth covered roller will be there, and the fabric is made to single fabric now, which is a thermoplastic. It is made to pass between the two rollers, and then what happens, the impression of the Moir comes onto the fabric. And this is fabric is going to be thermoplastic, that is heat sensitive. So, at higher temperature it will be receiving that particular impression, and thus it is going to be permanent on the fabric. So, when the light ray falls on it, it goes through all the there is flat surfaces, and thus it gives a watery effect. And so, moiring can be done, and it is a very beautiful pattern on the fabrics, and especially on sheer fabrics it looks very luxuriously lustrous. One more calendering that can produce very good patterns on fabrics is embossed calendering. Most of the times design is going to be self colored, because they are only the impressions that come on the fabric. In case of embossing, one thing is important is that the pattern or the design, whichever it may be, it should be engraved on one of the rollers. Two types of embossing is in vogue today. One is to produce flat designs, another one is to produce raised designs. To get the flat designs, the fabric is passed between the engraved hollow roller, which is at higher temperature, and also a paper roll. Fabric is made little wet, and then it is made to pass through these two rollers. Because it is at a higher temperature, and also it exerts high pressure on the material against the paper roll, and it gets the impression of the pattern that is engraved on the roller, and so the fabric will have a flat embossed designs. In order to get raised designs, what they do is that the paper roll also has the engraved impressions. The paper roll is made little wet, and after partially drying it, it revolves against the engraved roller. And then what happens is that actually the raised portions of the engraved roller will be impressed on the cloth roll, and thus you will find the design coming in both the things, which are one is positive and the other is negative like. And then when the fabric is passed between these two in the same conditions of high temperature and all, then the fabric gets impressed, and it goes even into the valleys of the design on the paper roll, and thus the design that is coming up will be much more raised and lowered. Like that, you will get a raised embossed design in case of this second method, wherein the paper roll also has the engraved impressions. Thus, we can produce embossed designs which look very good on the fabrics, and especially it looks like woven self designs. In this, we have to remember is that the rollers present in the calendering machines, the metal rollers and also the paper rolls and cloth covered rollers are there. No two metal rollers will revolve against each other. They may revolve against a cloth covered roll or a paper roll, but not against the other kind of metal roll. This will produce distorted fabrics, and also the fabrics get torn and all, and so this will be taken care of. And also the pressure of the fabric when it is fed and when it is drawn on the other side are controlled, so that there will not be any damage that is done to the fabrics. We will see what are the other mechanical finishes that are in vogue today in the textile industry. Tendering is one of the important finishes, or the final finish that is being given to most of the fabrics, especially when they undergo wet processing. During wet processing, the fabrics may shrink because there will be water, because it is a medium, either it is desized or bleached or dyed or anything happen, moisturized and all. When the fabric comes over here, it has so many wrinkles, and also the width of the fabric will not be proper. And so, the fabrics are to be tentered so that their dimensions are set. When the consumer goes to the market and buys a fabric, and they expect definitely a fabric with even width and also the length also properly made. And so, in order to achieve this, the fabric should undergo a tentering process. There are two types of frames. One is use of the clips on the other side, and that means there are chains both the sides, and the chains are set in such a way to suit the particular width of the fabric. If the width is 36 inches, yes, the difference between these two may be 36 inches. If it is 40 inches, the distance between the two chains will be 40 inches. Like that it is adjusted. So, the fabric may be gripped through the clips, or we have pins are also there which are vertically welded onto the chain. And so, the fabric is gripped in either by the pins or by the clips, and then it is taken inside. So, when clips are used, and there may not be any impressions on that, but if pins are used, pin holes will be present on either side of the material, and thus we can identify that it is pin tentered. And there is one quality aspect that is raising out of this tentering machine, because tentering, if it is not done properly, and there will be a problem for the final fabric. If it is fed in such a way that the warp yarns and the weft yarns in woven fabric are straightened when they are right angle to each other, then the tentering is done very well. And if it is not so, if they are fed in off grain, that means that one side it is going forward and the other side it is trailing backwards. It results into a off grain fabric, like it produces a skew. We call that particular fault is a skew, and which is a difficult process to straighten it again and all, and especially in the ready-made industries and all, it will be a problem. And then if the pressure is not properly made, and then if the center is going a little backwards than the two edges, then it forms into a bow. That is also a problem in the ready-made industries, or whenever a fabric is turned into a garment and all. And so, these two can be controlled by carefully controlling all the aspects of this tentering machine. And nowadays, there are so many controls that are coming up, and you have electronic eyes in order to see where the defect, and it automatically stops, and then it can be rectified. And so, with a lot of electronic controls nowadays, the machines are there, and so there may not be much problem, but still a number of ordinary mills are there in many places in India, and they are not that advanced, and so the particular problem prevails. And so, one has to take care of this tentering, and especially when after tentering, when the fabrics are printed, then again it is a havoc, and the printed fabric cannot be used again. But in case of thermoplastic fabrics, if tentering is not done properly, then what happens? It is set at the temperature, very difficult to alter those shapes. But in case of cotton and other cellulosic materials, it is easier, because if you wash it, then you can straighten the material, but not in case of thermoplastic fabrics. And so, tentering has to be done very well and very carefully, so that we will get a neat and good quality fabric. The next finish is the shearing. Shearing is generally applicable to napped fabrics and also the cut pile fabrics and all. So, when the fabric has a third dimension, like in case of nap fabric, and also in case of velvet fabrics, where the thickness is also important, because some fibers are protruded and made into form of fuzziness in case of napped fabric, like Turkish towels and all. And in case of velvet fabrics, extra set of yarns are present on the surface, forming the loops, and these loops are to be cut, so that we will be able to get the kind of velvet fabrics and all with third dimension. In case of napped fabrics, fibers from the yarns are being pulled, and they are very uneven, and so in order to make it even, that shearing is being carried out on these fabrics. The shearing machine consists of a cylinder containing blades which are placed vertically on that, and the principle is just something like a lawn mower, and it takes up the usually the protruding fiber ends or the yarn ends, and then cut it and make it even edged and make it smooth. Brushing is a mechanical finish that is applicable to napped fabrics and also some of the pile fabrics. Before they are passed into shearing machine or for giving some other finishes, usually the nap should be raised, and so it will be first of all brushed in order to remove any of these knots and other small fiber ends and all, so that it will be neat, and the raised portion will be picked up by the shearing machine and then it will be cut. In brushing machine, the cylinders consist of brushes which are placed on the rollers, and when the fabric goes along these rollers, what happens is the nap or the loops that are present will be finely brushed. Fragments of pieces of fiber and yarn can be removed and it becomes neater, and also if unevenness is there in the napped surfaces and all, it can be shown by raising it, so that the shearing machine will shear that and make it fine. Sometimes brushing can also be done before and after napping, or before after even cut pile or after shearing, you can say. So, napping is one of the mechanical finishes given to fabrics to resemble wool, and sometimes it is also given to wool fabric in order to make it more softer and all. And for actually napping the wool fabrics, we use some vegetable burrs and all, which are thorny things called teasels, and small pots like with the thorns and all, and one of the rollers will be having these particular teasels, and then the fabric is made to pass over that, and then it gets finely teased, so that the fibers will rise and give a beautiful soft look. But when it is to be produced in case of cotton and other materials where they do not have this kind of quality, then we can even do the napping for these fabrics. A napping machine, and which consists of 24 to 30 rollers, small rollers may be present, and each small roller called either pile roller or counter pile roller, and these will contain fine wires and also hooks, very small hooks will be present. And when the fabric is made to pass between a very big roll and between these small rolls, what happens is there will be a pile roll and counter pile roll next to each other. They will revolve opposite to each other. That means the direction of one will be anti-clock and the other one is a clockwise direction. So, this teasing action of these two, and also the kind of wires and these hooks and all present over there, and these will try to raise the fibers from the yarn and pull it. There are series of that around the roller. You have around 24 to 30 small rollers, and so the action of all these things will produce a good fuzzy surface on the material, and which later made even by shearing and then brushing of these fabrics. The napping can be either side or only on one side. If napping is only on one side, something like a sweatshirt and all, where they are napped on the wrong side and either printed or some surface decoration is done on the right side. So, the fabric is going to give lot of warmth when compared to the ordinary cotton materials. So, for producing this warmth, the particular napping is done to these materials, it is only one side. And some napped materials like the one which we use it for cleaning of the polished surfaces like glass and reading glasses and all, we use a napped material which is napped on both the sides. Sometimes napping is also set one side, having only one direction, and in another fabric maybe the face and the back are set in different directions, so that the fabric will have the right and wrong sides. Like that napped fabrics can be made, and there are advantages of napped materials. One is that it produces a soft fabric, that is one thing, and also it produces warmth, because the fabrics are becoming thicker, and the air spaces that are present in between will be increased, and thus it increases its insulative power, and thus the fabrics will be highly warm when worn. Napping is also used in order to take away the objectionable luster in some of the materials. And so, since the fabric is going to be soft and all, and it does not have the smooth, very smooth surface and all, and so the luster may not be that much in this material. And also sometimes some stains will be there on the fabric. In order to remove the stain, maybe it is very difficult and the fabric has to be processed again. And so, in order to camouflage those stains, sometimes they are also given a napped finish, so that the stains will be camouflaged and it will not be seen. And then coming to disadvantages, maybe to the consumer, we have to be careful. Some of the sleazy constructions in some of these materials may be covered with the nap, so that we will not be able to understand how the basic fabric is. And another one is that the some holes and some imperfections in the weaving may be covered with the nap, and so later when we use this material, it may not give that much performance. And so, we have to be careful with the napped materials. Napped fabrics are generally taken as a variety, and when fabrics are produced like this in nap, especially cotton, they are called as flannelette materials. The material which looks like a soft 2-in-1 on either side raised effect and all is called flannel in case of wool. And since cotton is being made to resemble that flannel by napping finish, it is called as flannelette. This fabric can be used for the children's dresses and all. It will be very soft and also it is more absorbent, and also so the children will like to be in this particular dress. It will be more comfortable for the children. Fulling is a mechanical finish given to wool fabric, because wool fabric when taken like worsteds and all, and it needs to be fulled. Unless you full it, the fabric will contain a sleazy construction and all, and so in order to make the fabric fuller, this particular finish is being used. And for giving this finish, we need only the moisture, the heat and also some friction, usually pressure is being given to these fabrics. So, they are made to full, so that they will not shrink later, and so this is being given, and so that the fabric becomes compact and there may not be much shrinkage for these fabrics. And so, this particular finish is given to wool fabrics, and it is only applicable to wool fabrics. The example for this fulled material is boiled wool jersey. That material is being fulled and the fabric is very compact. Heat setting. This is one of the important mechanical finishes that are being given to thermoplastic fabrics. Like other fabrics, other fibers otherwise, you find that there will be shrinkage in everything. And also when the fabrics and yarns are made, they are always under tension, and unless the tensions are removed, the fabric will not be in a proper condition for making of the garments. And so, these tensions or stresses should be removed before the fabric is made ready for end use. In order to do so, in case of heat set materials, and this particular finish is given. For heat setting the fabric is taken through the tendering machine, and then the fabric when taken inside, and the temperature and the time for which it is exposed will depend upon the type of the fiber used, because they have glass transitional temperatures at different temperatures for each fiber, and so they are set at the temperature for some time, and the time and also the temperature are controlled inside. So, the fabric is taken in a tender frame, gets into the oven where the temperature and temperature will be high, and the temperature will be suitable for the particular fiber type present in the fabric, and then it is exposed to a specific time, and then the fabric is taken out. So, once there, when the fabric is set at the temperature, and generally the fabric will not be distorted or will not shrink when the temperature is below the temperature at which it is set. That means that generally we will not go higher than the temperature, and so nothing happens to the material after laundering, and so we say that it does not require any ironing after washing, whereas cellulosic fibers and all, they do not have this quality of thermoplasticity. That means that they do not get set at that particular temperatures, and so they will be there will be some difference in the shape and all. So, we have to iron it, but these fabrics may not require that much ironing, especially polyesters and all. Maybe after 2-3 washes maybe we can go for ironing, but regular ironing is not required for these materials because they are heat set and the dimensions are set and nothing happens to the material at this particular stage. And also sometimes the heat setting is done with a predetermined shape, like we call it as a pleating materials. Pleated materials we can see in markets sometimes, that is the fabric is first pleated with the mechanical devices and maybe stitched or put up with a paper tape and all, and then it is gripped along the tenter frame and then the chains of the tenter frame, and then it is taken inside and it is set like that, and maybe with a paper backing or so, and then when it comes out and the pleats are beautifully made, and so the fabric will contain the pleats and it will be a durable finish on these materials. And nowadays even the garments sometimes they are made in some shape and then heat set at a higher temperature. Maybe there some resins are applied and then heat set at a higher temperature, and thus the shape will be retained in the material and the shape is going to be highly durable. Thus the mechanical finishes that we have learned to know are all are used for bringing kind of alterations in the fabric, maybe changing the some of the properties or making it more presentable to the consumer and making it more aesthetic in looks and bringing in more variety in fabrics. We are subjecting them to these mechanical finishes. And in all these mechanical finishes, even though the chemical changes do not occur, but still these finishes should be done at a controlled atmosphere and controlled conditions, so that there will not be any damage that occurs to the material.